Hello. Let's look at addition law of probability. We still continue our lesson on probability. Okay. So with the addition law of probability, this is where we have an experiment, and then with the given experiment, let's say there are two or more events, and you are looking at the probability of one event occurring or the other one occurring, or even both events occurring. For instance, let's say I have a set of numbers 2, 3, 4, 5 up to 10, and I'm looking at the probability of selecting, let's say, prime number. Let's say prime number or probability of, say, odd number. Okay, so we have, let's say, a set 2 to 10, and I'm asked to find probability that when I'm selecting a number at random, it will be a prime number or it will be an odd number. Okay, you see that this is the same experiment, and then I'm looking for the probability of either a prime number or an odd number. So when it happens that you are looking at two or more events in the same experiment, okay, then the law of probability can be applied here. Okay, where let's assume that we have event A, okay, and then event B in the same experiment. We are going to look at the probability that either event A or B will occur, or even both of the events are going to occur. So in probability, there's a probability of event A or B. Okay, we can say it is the same as probability of A union B. Then we can say that is the probability of A, or the or is the addition. All right, you apply your addition, or probability of what? B minus probability of A intersection B. All right, so the addition law of probability, okay, with the addition law of probability, that is why we have probability of either A or B occurring. This probability of A, or the or is or apply addition, or probability of B minus probability of both events what will occur. So let's say, for instance, in this case, I'll find probability of prime number occurring plus probability of odd number occurring, and then I'll come and look at the prime number and the odd number. If it happens that, okay, we will have a same number which is prime at the same time odd, then there is what? Intersection. So if there is intersection, what I'll do is to what? Is to subtract the intersection, and then I'll get my results. All right, it is like we asking to list, you have set A as 1, 2, 3, 4, and then let's say set B as 2, 4, 6, and then 8. If I ask you to list A union B, okay, what will be my A union B? It will be 1, 2, 3, 4, 6, and then what? 8. You realize that there is an intersection, which is what? 2, yeah, and then what? And then 4. But when you were listing, you just wrote them once. You didn't write them as 2 times. As you can see that it occurs in here. So that is the same thing applies to what? Why we subtract what? The intersection. So that when we find the probability of the union, okay, or probability of one event or the other one, okay, we do not write the intersection as what? As double. So we have to subtract what? Subtract the intersection of what? Of the two events. All right, of the two events. Okay, so when you are given an experiment, then you are supposed to find probability of one event or the other. Then the probability of one event or the other is the same as the union. Is equal to probability of one event plus probability of the other minus probability of the intersection. That is, if you can see in both events, you can see that there is a number here which is the same here. Okay, there's a number occurring in event A, and the same time you can see event what? In event B. then that becomes on the intersection, and then you subtract. Is that okay? So make sure that you become familiar with this particular formula here, okay? And then it'll be so simple to do. So we are going to solve some questions right now, and I believe you'll be able to understand. This is so simple. All right, let's look at the examples here. Number 1, a number is chosen at random from the set 1, 2, 3 up to 10. What is the probability that it is A, prime number, B, prime factor of 42, or multiple of 3? Okay, let's work with the B. Then let's start with the number 1 first, then we come to number 2 later. All right, so number 1, we said a number is chosen at random from the set 1 to 10. So 1, 2, 3, 4, 5 up to 10. So our set is 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. Okay. And it asks now, what is the probability that the number is a prime number? Okay, so before we come, because it's probability, let's find our number of possible outcomes, all right, or the sample space for the experiment. Definitely it's 10. Okay, then it's asking the probability that A, it is a prime number. So A, we are going to list prime numbers, okay? So probability of that it is a prime number. So prime numbers in the set given. 1 is not a prime number, so 2 prime numbers. We have 2, 3, 5, all right, and then 7. Okay, I think that is all. Okay, so the number of prime numbers, okay, one, 2, 3, 4. So we have 4. Okay, so the number of prime numbers is 4. All right. Then we find the probability of a prime number. That will give us what? 4 out of 10. And what is 4 over 10? I think that will be 2 on 5. Okay. 2 goes here, 2 goes here, 5. So 4 over 10 is giving us 2 over 5. Alright, so we are done with the A. Very simple. Now, let's go to the B. Okay. Prime factor of 42 or multiple of 3. So, this is where we are going to apply on the addition law. Prime factor of 42. So, we are going to look at prime factors of 42. So this is the B, prime factors of 42. Okay, so when you talk about, take note of the word prime factors. Okay, so they are not just factors of 42, but factors of 42 that are prime. We have a lot of factors of 42, but you want the factors of 42 that are only prime. Okay, so we are going to look at factors of 42 and list the prime. So if I'm talking about factor, 1 is a factor of 42, 2 is a factor of 42, 3 is also a factor of 42. Okay, what of 4? 4 is not a factor, 5 is also not a factor, 6 is a factor of 42, yes. What of 7? 7 is also a factor. Okay, what of 8? 8 is not. Okay, 9 is also not, and 10 is also not. Okay, so when we look at this, we have 1, 2, 3, 6, and 7. Okay, so we go by the selection is made from this set, so we don't go beyond the set given here. Okay, so when you are listing the member, don't go beyond the experiment. Okay, this is the set, and we are making selection for, so we cannot go beyond the 10 because the set is from 1 to 10. All right, and we list the prime factors. So these are factors of 42 from 1 to 10. Okay, but we are only going to consider the prime. So if it is the prime, then I'll get 2, 3, and then 7. So these are prime factors of what? Of 42 from 1 to 10. Then, since we are doing probability, let me talk about the number of prime factors. Okay. We will come to that. So that is giving us 3. Okay. So it is 3. 1, 2, 3. Then we also come to multiple of 3. So we are going to list multiples of 3. Okay. Multiples of 3 within the set given. So if it is multiples of 3, then I have what? I have the number 3, then 6, and then 9. Okay, so these are multiples of what? Multiples of 3. So number of multiples of 3, that will give me 3. 103. Okay. Then I'm finding a probability that it is either a prime factor of 42 or multiple of 3. So probability of prime factor of 42 or multiple of what? Multiple of 3. So let me use P and M for P for prime factor of 42 and M for multiple of 3. Is going to be probability of prime factor of 42 plus probability of what? Multiple of 3 minus probability of the intersection P intersection M. Okay. So this is what we are going to apply. So probability of the prime factor of 42 or plus probability of multiple of 3 minus the probability of the intersection. That is if there is intersection. Okay. So let's check if we can get intersection. Do we have probability of P intersection M? Okay, so let's check if there is intersection. Looking at prime numbers here and then multiples of 3. We have 3. Okay, I think it's only 3. So we have only 3 to be what? To be the intersection. Okay, so our number of prime number of prime factors of 42 intersection multiples of 3 is what? Is only 1. So we have only 1. Okay, just 1. So the number of prime factors of 42 intersection multiple of 3 is just 1. Okay, so therefore probability of prime factor of 42 or multiple of 3 multiple of okay, so therefore probability of prime factor of 42 or multiple of 3 is equal to what? Probability of prime factor of 42. Okay, so what is the prime factor of 42? How many numbers do we have here? So number of prime factor is 3. So that will give me 3. The whole set is what? Is 10. So probability of prime factors of 42 is 3. Because the number here is 3 out of the 10. Okay, the number of possible outcomes we have here. Or that is plus. Okay, probability of multiples of 3. How many are also there? They are also 3. So 3 out of 10. Minus the intersection. There is intersection between these two sets. So minus 1 over 10. Alright. So that can give us our answer. So this can be, they all have a common denominator as what? As 10. So 3 plus 3. 3 plus 3 plus minus 1. And 3 plus will give us 6. Minus 1 will give us 5 on 10. That is going to give us 1 on 2. So probability of prime factors of what? A prime factor of 42 or multiple of 3 is 1 over 2. It's 1 over 2. Alright. There is also a simple way you can work this question without going through all this formula. Is that okay? you can work this question in a simpler way without going through all this. Okay, what you just need is what is to list the prime factors of 42. So prime factors of 42, you know, we have what? 2, 3, 7. The way that we are going to solve this question is, he said, the question said we should find probability of a prime factor of 42 or multiple of 3. So it is just union. You are putting the two set or two events together. So we just list prime factors of 42 and list what? Multiples of 3. Okay. Then you count the 2 and divide by what? The number of possible outcomes. Then that is all. So it is just the union of the 2. Okay, that is the all. It's union. So you list the 2 sets, you count the 2 and you put together and divide by what? The number of what possible outcome. That is all. So you also write your multiples of 3. Multiples of 3, so 3, 6, and then 9. The probability of prime factor of 42 or multiple of 3. So the all here means union. So you are going to add the 2. Alright, so you are going to count how many numbers are there. 1, 2, 3. So you have counted this 1, 2, 3. So you don't count this one again as you are listing union. Okay, so the union of the 2 is 1, 2, 3, 4, 5. So 5. Then you divide by the number of possibilities, which is 10. And then 5 over 10 will give us 1 over 2. So the same thing. You see how simple it is. But take note that before you write this, then you have already listed what? Your set and then the number of possible outcomes. And then you go by the same way, you get your answer. Very, very simple. So let's look at the second question. M is equal to the set n is such that 2n minus 3 less than or equal to 37, where n is a counting number. Write down all the elements of m and find the probability that it is a perfect square or an even number. So first we have to list the element of m. So what is our m? M is the set n is such that 2n minus 3 less than or equal to 37. Okay, so we have 2n minus 3 to be less than or equal to 37. So this one we solve with 2n to find the n. Alright, so we have 2n to be less than or equal to 37 plus 3, and then 2n is less than or equal to what? 37 plus will give us 40, and n is less than or equal to 40 divided by 2 will give us 20. So n is less than or equal to 20. Alright, n is less than or equal to 20, and we are supposed to write down all the elements of m. So it means that my m is, and what is the n? N is what? N is a counting number. So a counting number starts from 1. So n is less than or equal to 20. So that will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and then 20. So counting number, we start from 1 and then we end at what? End at 20, because n is less than or equal to 20. So 20 is included. Alright. Okay, so we have been able to list the element of what? The element of m. We have found the probability that it is a square, a perfect square. So one perfect square, or we are going to apply the addition law or even number. So we are going to now our number of m, okay, is 20. So 1 to 20. So that is why we have to take note that our number of m is 20. Okay. Then we are finding a perfect square probability of, so when we are going to list perfect squares, okay, our perfect squares. How many perfect squares? So 1 is a perfect square. 1 times 1. So a perfect square, that is a number that when you multiply okay, by itself, the result that you get. When you multiply the same number by itself, the results you get. 1 times 1 give me 1, 2, 2, 4, 3, 3, 9, 4, 4, 16, 5, 5, 25 outside. You cannot, 25 is not included because it is outside the set, though 25 is a perfect square. So 1, 4, 9, and then 16. Then you write the number of perfect square. That will give us 1, 2, 3, 4. 4. So what you should note here is that because you have found probability of a perfect square or an even number, it means that probability of perfect square and even number is going to probability of a perfect square plus probability of an even number minus the probability of the intersection of the two. Okay. So then you also need probability number what do we call it? Even numbers within the set. Okay, so even numbers. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So number of even numbers, okay, is going to be 10. So we have listed our even numbers, our perfect number. We have been able to find the number of even numbers, number of perfect numbers. Okay, so we are finding probability of perfect or even. That is probability of perfect plus probability of even minus probability of what? Perfect intersection even. So let's see if we have perfect intersection even. Okay, let's see if there is intersection of the two sets. So we have 4 here, and then 16. Okay, so 4 and then 16. So it means that number of probability of a perfect intersection even is going to give us 2. 1, 2. So 2. All right. So only 2. Therefore, probability of perfect or even is probability of perfect number plus probability of even number minus probability of what? Perfect intersection even. Okay. So what's the probability of perfect? The perfect, how many? 4. We have the set to be 20 plus probability of even. How many even? 10 over 20. And the probability of intersection 2 on 20. Okay, so our answer can be, our LCM will be 20. That is 4 plus 10. That will give us 14. Minus 2. That will give us 12. So 12 on 20. And 12 on 20 can give us what? 4 can go into 12, 3. And 4 goes into 25. So our 12 on 20 is 3 over 5. So our answer is what? 3 on 5. That probability of perfect or an even number. Okay. You can also solve the same question in a simpler way. Okay, without going through all this. So, as I said, what you do is that you find a union, perfect union, even. So, what will be the union? If I'm supposed to find the union, so that means before you use this one, you have already listed your perfect numbers, you have already listed your even numbers, then you find the union of the two. So if I find the union, that will be 2, 1, then 2, 4, there is 6, 8, 9 is here, 10, 12, 14, then there is 16, 18, and then 20. Okay, so you are able to list the union, okay, of the two. So after you listed the union, then you say that probability of P or E. Okay, that is the same as the union. So you count. How many are they? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 over 20. Then you get your 315. So you see you are getting the same answer. You get the same answer. Alright. So this is about addition law of probability. Make sure to share and comment and like our page. I know I will see you again as we solve more questions. Bye bye.